Hey folks! Well, this time around I want to just play with some miscellaneous bits and pieces of Linux and Bash that might come in handy. Some of it this term, but certainly most of it later on in your stay here at VIU or your later Linux careers. So again, just a whole bunch of tools that might turn out to be useful. Let's see, I'm going to run through the theory of most of them first, and then we'll play with them in a little bit of practice. So, for most of these, again, you can do a quick Google and get better information on exactly what the options are for each of these. I'm just going to touch on the basics for each of them. Just do make sure that you're aware that the implementation is going to be slightly different on every different flavor of Linux. So, just something to watch out for. Alrighty. So, one of the first things we want to be able to do is to figure out where we left a particular file in our file system, right? We've all had the situation where we've edited a file someplace and maybe we kind of remember what the name is or part of the name, but we have no idea what directory we were in when we did that. So find allows us to go through and say, okay, here's what I want to look for. Here's the directory that I want to search and all of its subdirectories. And so the syntax is find the name of the directory that you want to search, the top level, and then the dash name option, and then whatever it is you're looking for, and we'll play with an example of that. So I want to find a file named, lab1.cpp or some such thing. And then the dash print tells it to display on the screen whatever it is it finds. And this will go through and search that directory and all of its subdirectories looking for something with this name and telling you where it is. And again, you can use things like the star and the question mark and whatnot to get things that match a pattern instead of just an exact name. So look for, labstar.cpp or some such thing, or lab1.star or whatever it might be. So find is for searching for files with a particular name. Grep is to look for something inside a file. So if there's a file, and I know somewhere inside it there's a line that has the word foo in it, then we can use grep and the pattern we're looking for, foo, and the file name, and it'll spit out all the lines of the file that have that pattern in it, tell you what line number it is, and show you the line. If you want to go through and compare a couple of files, you can use diff. So diff, the first file and the second file, whatever their names are, and it will show you all the lines in the two files that are different. And so again, just utilities that are handy at different points when we're experimenting with things. If you want to compress and uncompress files, it's gzip to compress, and it'll add the .gz suffix to whatever the file name is to show you that it's compressed, and gunzip to unzip it. So just to compress big files that we don't think we're going to be needing for a while. If you've got an entire directory that you want to compress, then what we do is create a single file that contains all the contents of that, so essentially archive the file, and then we can zip it or whatever it is we want to do with it. So you'll often find tarring and zipping used as a way to create an archive, compress it, and then you've got this nice compact file that's got everything from a directory in it. So for creating an archive, a tar file, the command is tar. It actually stands for tape archive from many, many moons ago. So tar, and then the options we'll typically want to use are -cvf for compress, verbose, and create a new file name. The name we want to call our new archive, and the name of the directory that we want to build it from. And then to extract them later, it's the same idea. We just use X for extract instead of C for create. Now, it'll add the .tar suffix typically to the archive that we create. So if you start seeing things like foo.tar.gz, what that means is that it's a tarred archive that's also been compressed. Let's see, what are some of the other bits and pieces we might look at? disk utilization, you're often going to want to find out something about the storage space in your account. Right? If you suddenly discover that you're out of disk space, you might want to find out where that happens to be. So the du for disk utilization allows you to do that. So du-s to get a summary, and the name of the directory tells you how much space has been used in that directory. If you leave off the -s, it goes through and actually lists all the files and things in it and all the subdirectories in it and how big they are. So you can get information on sort of what's going on, how much space is being used where. You might want to pipe that into a numeric sort so it actually gives you a list sorted by how big it is. And again, just different things that might come in handy as you're playing with this stuff. So let's actually have a look at some of this in action. So let's start off with a clear screen here. So we mentioned the find. Here, let's go to our home directory here. We mentioned find. Let's say I want to look for all of the files that I've got whose name begins with data. So I'm going to say find, and I want to search everything that I have. So starting in the current directory, dot, and I want to look for things that are named data whatever. And I want find to print that out for me. So this is going to go through and try and find all of them for me. So it tells me what directory they're in and what their full name is. And so find is a useful way to search for things, search for files named with a particular pattern. So let's say we go into our experiment there. And now I want to see if there's any lines in a particular file that contain the pattern blah. Knowing me, there probably are. So we'll do a search, a grep, for the word blah in any of the files named data something or other. So it goes through and it gives you all the lines that it finds. So in data.modified, there's 2 lines containing the word blah, and in data.text, there's also 2 lines containing the word blah. Right, so grep will allow you to find where things are, or where a particular pattern appears in a file. Now, if we want to go through and compare a couple of files, so we'll use cat to show us what's in these files first. So data.text has this in it, and data.modified has this in it right now. So if I want to actually do a comparison on 2 files, I can use diff and the names of the 2 files, data.text and data.modified, and it will show me the lines in which those 2 files are different. So it says the first file on one of the lines has this, and the second file on that same line has this instead. Right? So we can get a quick look at how things are different between one file and another. Let's see, what else can we do here? We mentioned zipping for compressing something. So let's go through and let's take a look at how big data.text is. It's pretty small. So it's just 46 characters, 46 bytes, but we can compress it. It's this small, I'm not sure compression's actually going to help much, but we'll see. So we'll gzip data.text and see how big it is now. And yeah, it actually wound up bigger because it was such a small file in the first place that the compression has made it take up a little bit more space. However, in general, if you're dealing with it, you're not typically going to compress something unless it's a pretty big file, in which case the gzip will actually make a significant difference. So gzip to compress it, gunzip to uncompress it, and we're back to the uncompressed version. We mentioned tar to create an archive from something. So I want to create an archive, so -cvf for create verbose file, and we'll call this basic linux.tar, and I want to create an archive out of everything that's in that basic Linux directory sitting there. And it goes through and it tells me all of the files that it added to this archive. And if we take a look, again, we see we've got our newly created archive file here. Actually, let's see how big that one is. /l basic Linux tar. Yep. And oh, typo in the name. Alright, so it tells me how big it is, and all of this stuff from the other directory has been archived in here. The other directory is still there, but I've now got this archive as well. So I can zip that as well if I want. Let's gzip. I'm going to be lazy and just say gzip everything that ends in .tar. And there we have our tarred and zipped file, and it has actually compressed it significantly this time. So instead of using 30,000 bytes, we're now using just under 4,000. And again, if you want to go the other way, you unzip it first, and then we can use the -xvf in tar to extract from the archive. And it will have gone through and extracted everything from that file. And again, it tells you what it's extracting as it does it. Now, there's all sorts of other options for these, but just in terms of the basic utility, that'll do it. All right, and then the one other thing I mentioned was the du. So du-s, if I'm in my home directory and I say dot, it tells me how much total space I'm using. So 1144 bytes or K. And then if I want to get a breakdown of everything by file, I can just use a du, and that just goes through and lists everything that's in there. If I want to sort it numerically, right, that goes through, and at the end of the list here, I start seeing whatever's biggest in my directory tree. So, all sorts of things you can have a play with. Again, experiment away, do some Googling and see what works, check out the man pages, see what options are supported. But these are all things that at one point or another are going to wind up coming in handy. All right, I will leave it there for now. I think in the next little while we're going to drop some of the Linux and Bash stuff and get into looking at software development life cycles.